Hey, welcome back to Mr. P Helps with Math. This is Calculus AB, Unit 1, Day 1 happens to be, as we're going to explore some of these prerequisite skills that you should have from prior math classes. And we're just going to talk about the notes, and we're going to jump right into it, into our first question. So we have here some factoring. So we're factoring with the leading coefficient. So there's a couple of different ways you can do this, but one way you're going to do it is multiply that a term times that c term. A just happens to be the number or the coefficient in front of the x squared, and the c term is the constant. And that ends up giving you 60. And then what you're looking to do is trying to split that 60 into a number that multiplies, gives you a product of 60, but also has a sum of 19, which happens to be 15 and 4. Multiply, you get 60, add it together, you get 19. And then you can factor out the GCF by splitting this in half. And then if after you split up both of these, take out the GCFs, then you can see that these two numbers can be put together in one factor, and then whatever's left over is the other factor. And then you do the exact same process for the bottom, as you can see I've already done. Now what ends up happening here is we end up with a whole. So we have an x plus 5 on top in the numerator and the denominator, and anything divided by itself cancels itself out, and that's what gives you that whole. So once you remove that, then you just have this as your answer. So 3x plus 4 over 6x plus 1. On the next question, it looks like we're finding the point of intersection between these two terms. Now, I chose to use substitution method. I chose to use, well, if y does equal x minus 1, well, this y should also equal x minus 1. So I plugged in x minus 1 into this equation, and then I solved for x, because once you have one variable, then you can isolate that one variable to find that one solution. And then once I found the value of x, then I can plug it back into either one of these equations and find what y is, and it looks like we have our point at 2, 1. Happens to be where these two intersect. On the next question, we have a composite function, f of g of 2. So in this question, we have one function for f of x, one for g of x. And what I'm going to essentially do is I'm going to find the value of g of 2 first, using the g of x function. So in other words, I'm going to plug 2 in for x and solve it. So g of 2 ends up being, so if I put 1 and I put a 2 right here, that gives me 1/2. And now that I know g of 2 is 1/2, then I'm going to find f of 1/2, because that's really what g of 2 really is. So essentially I go over here to the f of x function, I put 1/2 in here into the x. Now I chose to solve it like this by getting rid of the 1/2 by multiplying both top and bottom by 2, and therefore giving me the answer of 6. All right, for the next question, looks like it says state the domain. Now the key here is that a square root cannot ever be negative. Otherwise, you know, it would be an imaginary answer. So it'd be a negative answer. So it can't be negative. So in order for it to be a real answer, it's got to be positive. So therefore, I set this value inside, set it equal to, it has to be greater than or equal to 0, can actually be 0. And then I solved it, and therefore giving me an x has to be less than or equal to 1. All right, so for our next question, this is basically a question where you're just following the order of operations. And I even wrote here on the notes that you basically do whatever's on the most inner first. So I'm going to start right here where it says 3x plus 1, and I'm going to use the distributive property. Now, you might be wondering, what am I distributing? I don't see a number right here. Well, you're actually distributing -1. There's an invisible times 1 there, so you are actually distributing -1. So I'm going to do this times this and this. So I'm distributing that -1 to eliminate these two parentheses, and then I go through the same steps. I multiply by 3 by all three of these terms to get this, and then I multiply everything by x. Now I know I could have combined these like terms first, that is an option, but sometimes in math there's several different ways to get the exact same answer, and yes, you will get the exact same answer no matter which way you solve it. All right, so we have a complex fraction in the next one, and one of the tricks here is to try to get rid of both of these denominators. One of the tricks here is basically to multiply by the product of the two denominators. 2 times x is 2x. So if I multiply everything on top and everything on bottom by 2x, then I'm going to be left with something that looks like this, which now I can solve by factoring out the GCFs. That will eliminate 2x plus 1. Well, it works out nice and perfectly. Then we get 1/2 x as our answer. Or x over 2, that's the exact same thing. All right, so now we've got ourselves a SOHCAHTOA question, so a trigonometry question. So in this case, we know that sine of theta is opposite over hypotenuse. We know opposite is x. We know hypotenuse is the 2√3 over here. So then I know sine of 30 happens to be equal 1/2, so I know that, all right? This happens to be one of those special angles. So sine of this would be opposite over hypotenuse. So I know that this over this must equal 1/2 because that's what sine of 30 actually equals. And I know that, and you should have that memorized. And then I cross multiplied and I solved for x. And once I found x, I got root 3. All right, so for the next question, we're trying to find the inverse. And anytime you try to find the inverse of something, you essentially are taking your x and your y and you are switching them. So if your f of x is your y and your x is over here, you're just switching those two around. So I'm going to place y in for all those places where x is, and I'm going to put x where the y is, and that's where I get this. Now, I am going to use a lot of Algebra 2 skills, maybe even some pre-calc skills. I am going to exponentiate first. Anytime I have natural log, that is the same thing as log base e. Should have learned that last year. And the inverse, I'm sorry, not the inverse. Yeah, the inverse of log base e happens to be e to the power of. So the inverse of log is exponentials. So essentially, when I raise everything to the e to that power, e to the power of log base e cancels each other out because they're inverses of each other. And so this cancels out, and I'm left with just y over y minus 2. So then whatever I do to one side, I must do to both sides, of course. So this x gets raised e to the power of x as well. Then I'm going to multiply both sides by the denominator, so these two cancel out. Because remember, I'm trying to find just y, so I can't have two y's. I'm trying to find y equals something. So that's going to give me this, which I can distribute this using my distributive property. That gives me what's over here in pink. And then since I'm trying to solve for y, I'm going to get the two y's on the same side. And then once I've done that, I can factor out the y and then divide both sides by what's on the inside. And there's my answer in simplest terms. All right, so the next question, this is actually something you're going to be doing later on in the year, which is using the limit definition of a derivative. But for right now, we're basically just going to take and plug in whatever they give us in for the x. So we're plugging in for the x. In this case, if this is the x, this is f of x plus h, which means they're telling us that x squared minus 5 is y. So we're going to take that entire expression, we're going to plug it in for the x, and then we're going to solve it. So if we have x plus h minus 5, so we're taking this, x plus h, plugging it right here. Let me go back to my pen. If I take this expression and I plug it in right here, which you can see I've done in blue, and then I'm also going to, for f of x, I'm going to do the exact same thing. I'm going to take x, I'm going to plug it in right there, which honestly doesn't really change anything. It's going to be the exact same thing. It's still going to be x squared minus 5. And then I'm going to just simply solve it. Now, you're going to notice what I did after I did x plus h squared. That gave me this. And I used sort of the shortcut method of doing it, times itself, multiply h times itself, and then the outers and inners of FOIL will add up. So I just doubled just this times this. So that was my shortcut method of getting to here. And then I'm going to cross off anything that is the same. So x squared and minus x squares cancel each other out. 5 and negative 5 cancel each other out. And I simplified it down to what I have in purple. Factored out the h. H's cancel out top and bottom. And then I'm left with my answer, 2x plus h. All right. On the next question, we've got a compound inequality. Now, the key here is we're going to solve it twice. There's two different answers. We're going to solve for the lower limit and the upper limit. So I'm going to circle what's in blue. I'm going to solve it over here. Now the key to this, and both of these actually, is that whenever you divide by or multiply by a negative number, you got to always flip the sign. So this less than symbol became a greater than symbol. So we know now that x has to be less than 10. And you're basically just using regular algebra to solve. Same thing with the pink one, is you're just going to use your algebra to solve, but then once again, once you're multiplying both sides by a negative, which you'll eventually do, you do have to flip the sign. So the less than becomes a greater than. Can't forget that. And these are two different ways to write the exact same answer, but in calculus, please be more used to using this notation. So this is the interval notation rather than the inequality signs, because this is what we're more likely going to use over the course of the year. And our next question, we have a very similar question to what we saw before, so solving using leading coefficients. Once again, I think we're going to have a hole here. Let's see, actually there is no hole, so, we're just looking for the zeros. All right, so when you're looking for zeros, you're just looking for when the numerator is 0. So if you're looking for asymptotes, that will be when the denominator is equal 0, because 0 divided by anything is a 0. So I just take all three of these factors on the top, set them equal to 0, and solve. And this is not a real answer because 2 can never equal 0. That's an imaginary answer. So it looks like we have two answers of 4 and negative 3. For this question, let's see. I'm going to factor this kind of the same way I factored all the other questions. So just like if this was x squared and this was x, I'm going to solve it just the same way. Because you'll see if you use the FOIL method on this, you will just get back to this previous answer. So really, I'm just factoring it like I normally would. Now, I do need it to be 9, and now you're probably wondering, well, how did I know I needed it to be 9? Well, I know that I needed it to be 9 because I used that formula used back in Algebra 1 of b divided by 2 squared. And b happens to be negative 6. Negative 6 divided by 2 is 3. 3 squared happens to be 9. I needed this c term to be 9, so that's why I'm subtracting 3 from both sides. And then it's just a matter of using Algebra 2 skills to solve from there. All right, next question we have is, okay, so properties of logs. Now, anytime you have a coefficient in front, you can really just slide this up into the exponent. So I basically did that first, turn it into green, and then I could have done this several different ways. So the way I did is I just raised it. 4 to the third power happened to be 64, and then 6 to the 1/2 power just square root of 6, and 24 to the 1/2 power is basically just square root of 24. Then I use my properties of logs, and then I notice that they all have the same base. Since they all have the exact same base, I can basically just put them all together. Anytime it's addition, it turns into multiplication. So this answer times this answer, and then divide by this answer. So now I've got it into one base, and then I use my I simplified them. I simplified my square roots in order to get both of them square root of 6, and then I simplify from here. 64 divided by 2 is basically 32. What power of 2 is 32? And the answer is 5. All right, next question. It looks like we have, so for this question, I'm basically using system of equations. It says if x squared plus b times x plus c, if g of 2 equals 0. They're telling you it equals 0, so I put a 0 right here. I'm basically just going to put 2 in for my, that's my x spot, basically. So I'm going to put 2 in for x because it's g of 2. So as you can see, that's what I get here. And then I did the exact same thing for this one down here because it says g of negative 3 also equals 0. And then once I did that, then I just subtracted top minus bottom using system of equations. And I was able to solve for letter B. All right, so for the next question, so we have natural log of x minus 2. Minus 3 times natural. Okay, so once again, I did the trick of moving this into the exponent spot. And remember, natural log really is log base e, so I exponentiated both sides to get rid of this part. And then I multiply both sides by 8, as you can see, to get rid of this. So these canceled out. And then I basically just used more algebra skills in order to isolate isolate x. All right, next question. Probably going to be the easiest question that is on here. So sine inverse basically just means what angle measurement is going to give you 1/2. So this is just something you should have memorized. You should know that sine of 30 degrees is 1/2. So this is really 30 degrees. And then cosine of 30 degrees, you should also have memorized, is root 3 over 2. So really this is just memorization. And that seems like that's all the questions that we have. Now remember, this is not everything that you're expected to know in calculus, but this is a lot of stuff from Algebra 2 and pre-calculus that you should have well solidified at this point. If you have any questions, please ask me in class, and I'll be more than happy to help you out with any of these questions personally. Thanks again for watching, and have a wonderful day.